All right, now let's have a look at question 1I. And what they say to you is convert a viscosity of 1.5 cp to SI units. So I just made a diagram here. I just want to walk through it with you. We know in the metric system, if I asked you, hey, can you express a mass for me in the metric system? You'll say sure. And you'll express that mass in kilograms. If I asked you in the CGS system to express a mass for me, you know the base units there are centimeters, grams, and seconds. And so grams will be the unit of choice. Similarly, for viscosity, in the metric system, we use the Pascal second. And in the CGS system, we use the poise. That's P-O-I-S-E. So I just want you to keep note of that. And now that you know that, we can proceed with the question. One more thing, if you go to your data sheet, you'll see that the base unit for the poise is the gram per centimeter per second. And essentially what this is saying is, how many grams of a substance do I need for it to move 1 centimeter in 1 second? So you can picture something like honey. If I needed honey to move 1 centimeter in 1 second, then I would need to have quite a bit of honey for it to pull itself down. But if I had water, you just need 1 drop of water and you know that's already going to move 1 centimeter in 1 second. And so the question is just how much mass do I need to move this thing 1 centimeter in 1 second? All right, so that is kind of the definition or the base units of viscosity in the CGS system. Now we can begin with the question. So they say to you convert 1.5 cp to SI units. Now this is just personal preference. I cannot operate with prefixes. My brain just doesn't compute that way. So 1.5 cp I'm going to change to, you remember C is for centi, so that centi is times 10 to the minus 2 and then poise. So 1.5 cp is exactly the same as 1.5 times 10 to the minus 2 poise. So all I did was I replaced the C here with times 10 to the minus 2. And then if we go back to what our data sheet says, we know that 1.5 times 10 to the minus 2 poise is the same as 1.5 times 10 to the minus 2 grams per centimeter per second. And now that we've got this down, all they want me to do is convert this to SI units. So you know your SI unit system well. The base units are kilograms, meters, and second. So 1.5 times 10 to the minus 2 grams. Oh, that's not a good straight line. Grams per centimeter per second. All right, so I always like to write down my target conversions. I want to convert grams into kilograms. I want to convert my centimeters into meters. And fortunately, seconds is the time base unit in both the SI metric system and the CGS system. So we don't need to convert the seconds. All right, so I want to get rid of grams, right? So I'm going to write grams at the bottom and kilograms at the top because that's what I want. So I know that 1,000 grams gives me a kilogram, and that's pretty basic. And now we can cancel grams and grams. Okay. Next thing I know is that centimeters needs to go at the top, and that way centimeters at the top cancels with centimeters at the bottom. And over here, I can convert it into meters, and I know that 100 centimeters gives me a meter. So if I put this down in my calculator now, oh, and of course you can cancel the units as well. Centimeters cancels with centimeters, and I'm left with kilogram per meter per second. All right. So this becomes let's change back to black. 1.5 times 10 to the minus 2 multiplied by 1 multiplied by 100. And that is all over a 1. Remember, this is 1 centimeter second. That's 1 times 1,000 times 1. Remember that this step here is not necessary. I'm just doing it for pedagogical reasons. That is the word, for teaching purposes. And I end up with 1.5 times 10 to the minus 3. And my units were kilograms per meter per second. And if you go to your data sheet for the metric system, 1.5 times 10 to the minus 3 kilogram per meter per second is exactly the same thing as a Pascal second. And that is your final answer. Okay. So we are done. Now, if you watch the previous example, you'll know that there's a quicker way to do this if you're prepared to do a little bit of memorization. And here's how I'm going to make sure that you remember it, or hopefully remember it. So I remember that 1 CP is 1 millipascal second. Okay, let's put this in a box. This is the only thing that I remember when it comes to viscosity. So I don't know if you know who Gandalf is, or Gandalf. Gandalf, he's basically a wizard. And so you can see the CP kind of looks like a wizard with his robe, right? And he's standing here with his hat, okay? So this is Gandalf. And his famous line from Lord of the Rings is, "You shall not pass." And so over here we've got, "You shall not impasse." So 1 Gandalf is equal to impasse. And so Gandalf says, "You shall not impasse." And that's how I remember that 1 CP is 1 millipascal second. So let's just try this example again using this conversion, right? Someone tells me, "Hey dude, I've got a viscosity of 1.5 CP. You immediately say, okay, 1.5 CP is exactly the same as 1.5 millipascal second. And remember, I told you my brain doesn't compute with prefixes. So this milli is going to change to times 10 to the minus 3. And then Pascal seconds is left over. And just like that, in a split second, you can convert from CP into Pascal seconds, which is the base unit in the SI system. So thank you for watching. Let's move on to the next question.